wonderful person, this is Anton, and in this video we're going to go on an adventure and we're going to try to find life in our universe. Actually, not just our universe, as close to Earth as possible, but using mathematics. Welcome to What the Math. Well, we're not actually going to do any math, don't worry. I know not everyone here is a big fan of math, and I know this channel is called Math, but we don't usually do a lot of math. But we're going to let Space Engine do the math for you. As a matter of fact, the way that algorithm in this simulation/game works is that it actually uses realistic science and very realistic scientific concepts to try to recreate planets and stars and things around those stars, and also life in our universe. Now, in this particular video, I actually wanted to see how close can we actually find life to our planet Earth by using Space Engine, and then we're going to need to go and check out this planet and try to see if it's anything interesting. There's actually a very easy way to do this, and I'm going to guide you through this today. But the whole point is to see how much of life we can actually discover very close to us. And I haven't really used the search function in the new version of the game just yet. But I am very excited to try it right now. Now, to do this, what we have to click on is this button right here, and basically here we have to go under filter settings. So I think I actually did the search previously, and you can see that the planet closest to us within about 10 light years that has life is only planet Earth. None of these other planets actually have anything. In the older version of the simulation, there was a randomly generated planet around Proxima Centauri that actually had life on it, but it no longer exists because the randomly generated planets were removed and the actual Proxima Centauri b was added. But we are going to do the following. So we're going to click on filter settings and look for something that has unicellular or multicellular life. So basically something that has some kind of organic life. We're not going to be looking for exotic life because it's very hypothetical, it's very theoretical. We have never discovered any non-organic life, basically life that is made up of something that is not carbon. Hypothetically, there's at least one element that you can use to create life, and that's silicon, because it's very, very similar to carbon in its composition. But we've never found anything anywhere, so for now we're going to ignore this. So let's look for any kind of life near us. So if I click OK, only solar system shows up within about 10 light years. Let's increase this to 100 and try again. And look at that. And just like that, we've discovered plenty of life out there. This is once again mathematical. It's not really realistic. But based on, I guess, the principles of mathematics, you could potentially find life as close as, it seems the closest one is about 13.4 light years away from us. Oh, there's a Gliese system. That's really cool. Okay, so we have, and this system actually has two objects with life. So we're going to visit maybe these two. Is there anything that has more than two? Let's actually scroll through these really quickly. And yeah, there's actually some planets that have 3 planets with life on it. One of the named ones here, Mu Cygni, and a few other objects. That's really, really, really amazing. But let's actually just focus on the ones that are closest to us first. Starting with this object with a funny name. This is, I think, a star known as 2MASS J072222760. It's a brown dwarf, actually. Very, very interesting. And this brown dwarf, at a distance of about 13 light years, which is right here, very dark, very gloomy world. This is actually, by the way, an actual star in a sense. Well, it's not really a star, it's a brown dwarf, but this is a central object. And let's see if it has something around it that has life. And look at that. We've discovered an object right here at a distance. Actually, it's hard to tell the distance, but it's basically about 2,500 kilometers in radius. And this is what it looks like. And it does seem to have some kind of a moon orbiting around it, as far as I can tell. It's very difficult to see here. Maybe if we increase the brightness a little bit here, we'll be able to see something. This is the highest brightness I can go to. And okay, so that's what this object looks like. And interestingly, there is, according to the simulation, life here. And by the way, that's the main star object right there. That's the brown dwarf. So I think it'd be fun to actually see what the surface of this looks like. I don't think we'll be able to see any life per se. But I think right now I'm standing on the surface of this extremely dark world, and somewhere out here there is organic multicellular subglacial life. Basically, it's a life that lives inside ice, the ice shelf that's on top of the planet. Alright, well that's not as exciting as I thought it would be. We can't really see anything here. So let's go try the second object, which is Gliese 83. And this object actually has two planets that have life around them. This is at a distance of just, I think it was 14 light years. Is that what it said here? I think it was about 14.68 light years away from us. So this star is a red dwarf. This is similar to Proxima Centauri or TRAPPIST-1. And it seems that it actually has two moons. These are not planets, but moons that have life around them. So there's a gas giant here. Or is it a gas giant? It's a sub-Jupiter. Yes, so it is a gas giant. And this gas giant has at least two moons that have life. So this one, oh wow, this is a beautiful, beautiful object. So there is some kind of organic unicellular subglacial life. And because it's subglacial, we won't be able to see it, unfortunately. And then there is this here, organic unicellular subglacial as well. So it sounds like these are equivalent of, in a sense, Enceladus and Europa in our own solar system, where we expect there to be a lot of different types of life underneath the ice. At least some people do, because hypothetically you could definitely have life that not just lives but thrives underneath the ice of an object like this, because you could have things like hydrothermal vents down there that could actually provide enough heat and enough minerals for any life to live and thrive. And we have this we have these on Earth as well. We discovered them many years ago. There's a lot of life around these hydrothermal vents. Alright, so we won't be able to see anything here either, unfortunately. How about what's the next here? So this object, also red dwarf at a distance of about 16 light years, or almost 17 light years. Wow, it looks a lot different than the previous star. Okay, I think this is a planet, right? Nope, it's once again a moon. So yet another moon with more organic multicellular subglacial life. So once again, life that exists underneath the actual planet. So meaning that we won't be able to see anything on the surface. Even if we land here, all we'll see is basically just the surface itself, but no life whatsoever, because all of it is inside. And we can't really go there, unfortunately. Alright, I'm not actually going to stop until I find something we can take a look at. And normally it's just basically a change of color, but still, it's better than nothing. So let's go to number 4, and all of these are so far way closer than I expected them to be. And this is actually a star that has a name. This is Alta here, which is a very bright star. It's one of the most famous stars in the night sky. And it's used for navigation, it's used for a lot of other things. And didn't really expect to see this here, but look at that. We have a binary planet, right? Yeah, I think so. I think it's a binary object of some sort. And its partner seems to have life right here. Cold, airless mini Aquaria with life, and it has, oh no, not again, once again, subglacial life. So this seems to be the most popular life we've found so far, and it does make sense because, you know, planets like Earth are relatively rare. It's very rare to find a planet that actually has basically life-supporting conditions, so liquid water, low radiation, and basically all the nutrients you need. It's more likely that you'll find all of this underneath the ice inside the liquid water ocean that's inside the planet. And many planets and moons will actually have liquid oceans similar to Enceladus and similar to Europa. Okay, next object. And we have something else here. This is Ross, I think it says 556. It's hard to see, the letters are kind of small. And look at this, this is a beautiful planet, and guess what? This is actually aerial life. Multicellular aerial life. Which is basically microbes that live in the atmosphere, and I think maybe this is why it's so purple. And what's really cool about this particular example is that this is what we think might be happening on Venus. There's a huge body of scientists that believe that Venus actually has life in its atmosphere, in the upper atmosphere, because we've actually detected patches of unusual activity, specifically things like ultraviolet light being absorbed, that really makes no sense, and it seems to be seasonal too, so it makes even less sense. So this right here, this thing, this what you see, that could be life. This could be bacterial life inside a, well, I think this is actually a gas giant, Jupiter-like object. But we are actually now looking at extraterrestrial life inside another planet's atmosphere. Obviously not that exciting, but at least we can finally see something. Okay, so can we actually find any terrestrial life? So something that actually lives on the planet, not in the aerial atmosphere. Oh, that's a beautiful planet. This is something that you don't see very often. Okay, so let's go and find some terrestrial life. And pretty much everything in this list, with the exception of obviously Earth and this other star about 24 light years away from us, Ross 556, everything else is basically subglacial life. None of them are anything else. This one was aerial. So instead, what we're gonna do is we're gonna choose a biome this time and search by biome, because actually marine is good too. Because I want to find something. We want to find something that looks a little bit different. So let's see how close we can find any kind of terrestrial life to our planet Earth. And looks like we discovered 3 more objects. 2 of them are procedurally generated. One of them actually exists, HIP or HIP 108812. And let's actually go and jump to this object, just to check it out, because it does have one planet with life on it. And so here, look at that. This is it. This is the planet that has both terrestrial and marine life. We got really lucky here. We found both. And if we actually maybe land on it somewhere, we might start seeing patches of like green stuff. That usually indicates life, at least in this particular simulation. And I think whatever this is, this might be actually it. This might be some sort of a algal growth or some kind of a plant life that is unique to this planet. Let's go check it out. Let's go actually zoom into it. We're going to try to land here, and hopefully this is maybe what I'm looking for, because this is a completely different color and it actually has different texture. So is that it? Yeah, look at that. This is it. Terrestrial, weird, extraterrestrial, that is, life. It's purple. It's purple plants or algae or something. Alright, cool. Not maybe as exciting as I hoped it would be, and possibly not as exciting as you thought it would be, but nevertheless, that's actually how we're probably going to find first extraterrestrial life anyway. The reason why this is cool is that if we actually are able to discover terrestrial life on another planet, it's probably going to be through the interaction that it has with its atmosphere. So it's really the effects of life that we're going to discover first, not the life itself. Like for example, you know, on our planet, an alien species would be able to detect us simply because there's a lot of different exchanges of oxygen and CO2 that happen a lot quicker than they would be happening naturally. And so that's how you would find life on Earth. Similarly, it would be here. So maybe this planet is actually green and whatever color this is because of this unusual algae that seems to be growing on the surface. And so basically this is it. This is the closest planet to our planet Earth that seems to have any terrestrial life on it. The object is about, what was it, 65 light years, I think, away from our planet. Let's just double check. By looking at Earth directly, yeah, approximately 65 light years away from us. And every other object we found, and I actually found over 100, only had subglacial life, which would actually be very difficult to detect, because even if it exists in our own solar system, like on Enceladus and Europa, we still haven't found it. We don't really know how to easily identify it. But anyway, that's all I wanted to show in this video, and hopefully you enjoyed the adventure and the exploration using a little bit of mathematics without actually doing math, of looking for life out there close to Earth. The actual math behind it is relatively precise, but also only based on common understanding of how life could form. It's very possible that life is actually a lot more widespread than we can even believe, and it's very possible that it's actually everywhere in every single star system out there. Or it could be nowhere. Maybe we are absolutely unique. This is actually going to be the century when I think, or I believe at least, we're going to discover either extraterrestrial life or finally find the explanation for why we haven't found anything. So in your lifetime, you're actually very likely are going to finally get the answer to why we haven't found extraterrestrial life yet. Anyway, come back tomorrow to learn something else. Thank you for all your support. Subscribe if you still haven't, and click that bell button to be notified about future videos, and space out, and as always, bye bye.